everybody. Welcome to Houdini Hangout. Glad to have you guys with us tonight. This is the first Houdini Hangout of the year, and glad to, again, have you guys with us. Glad to take a little break and kind of get back to some stuff here. If you notice anything different at all tonight, as far as streaming goes, just let me know. I did over the break kind of switch up my streaming setup a little bit. So if there's anything weird or off or anything like that, just let me know and I'll try to get it fixed ASAP, but pretty sure everything should be working good and be pretty similar to what you guys may have seen in the past if you've joined the stream before. Yeah, my name's Peter. I host the stream here. And tonight we're going to be covering the Joy of Vex, which is a cool series that Matt Estela put together on his cgwiki. And it's just a really great way to kind of get introduced to Vex, and kind of ramps you up into learning it in a whole bunch of different ways with the different concepts, kind of slowly, a day at a time maybe is kind of the idea, but we're going to kind of try to do a couple days worth here at least. I have kind of planned to do 2. We'll see how quickly everything goes and how that all works. But yeah, so the idea here is that we're going to go maybe for the next few weeks or the next few times I'm able to stream. There might be a couple disruptions in there. In fact, I know of at least one where I will be out of town in the next month. So we're going to try to do it as quick as we can, but as thoroughly as we can. And after the fact, if you're watching this, hopefully there'll be some chapter markers in here that'll kind of say what specific sections kind of we're talking about in each of these videos that I'm going to do. This again is going to be part 1 of the series, unless something goes terribly wrong, and then we'll call this part 0.1 and we'll go from there. But it seems like everything's going fine with the stream from a technical standpoint, so that is good. Yeah, I think from a coding standpoint, we'll be able to get through this pretty straightforward today. I also have a couple new little features on the stream as far as things to help you visualize maybe what I'm doing. I've got like a little key pop-up that'll show up on screen now. So hopefully that's something that you guys enjoy and helps you. If not, let me know. You can always be a part of the Discord channel and let me know on there anything that you might have for suggestions for the stream or for topics and things like that. I've kind of overhauled that as well. There's a new announcements channel. There's some, more of a forum post for topics and things like that, just so we can be a little bit more organized and I can keep track of some of the things that, we're looking to do in the future or things that people have suggested and are interested in. Now, the reason I'm doing Vex to kind of, hey, KG, Happy New Year. Happy New Year. Glad to have you with us tonight. Oh, I had a little pop-up on my screen here. That was kind of weird. Yeah, Happy New Year, man. Glad to be back after, a week off for me, which is good from kind of everything. Had a huge snowstorm in my area, which was not super fun, but lived through it, so that's good. Anyways, so yeah, let me just actually, before we go any further here, I'm just going to pull up the Houdini Hangout website, and we can see, I'll show you this on the, let's do this, sorry. All right, so here I am. But this is the more important part here, the upcoming events. I have this set up here, and it's going to be talking about some of the things that are coming up, like when the upcoming streams are. I've kind of updated this a bit, so it'll show you upcoming weeks and things like that. Vex and Quaternions. Yeah, we'll get to Quaternions. We're not doing that tonight. We're going to kind of slowly break through it. But yeah, Vex. Yeah, let's do it. We're going to get our brains full of some code, and hopefully even if you're familiar with Vex, there's some little details in here that are nice, and it'll kind of get you going in the whole thought process of like how to best work with this stuff. But anyways, so I've got the dates in here so you can see these things. Yeah, so hopefully that's helpful. If you want to check out, upcoming topics and things like this is kind of the best way I found to do it. We'll see how things go. Like you can see here that there's a week in between there between 18th of January and the 1st of February where I will be out of town, so I won't be able to do the stream that night. But we're going to see kind of how things go with this Joy of Vex series. It might take a decent amount of time, maybe we'll get through a lot of it. I don't know. Hard to say. I don't want to go too fast, but also don't want to drag it out too long. So I actually had a nice little conversation with Matt today just to make sure, I wasn't stepping on his toes or anything like that as far as posting this, online and kind of going over his stuff that he's put together. So I chatted with him and he was, hey, how you doing, man? Welcome to the stream. Thanks for being here. Hat tip. So yeah, the Mr. Estela is in the crowd. Welcome, sir. So we're gonna do this kind of as best we can and see kind of how things progress here. So hopefully, Matt will be in the background maybe a little bit here and will correct me if I make any major missteps. But hopefully I can get everything right and to his liking, to everyone's liking. But anyways, So I downloaded a file that he provided on the wiki, so we can kind of all start from the same spot. Obviously, this stuff can be done really with any kind of geometry within Houdini, but he kind of just added in a couple of pieces of test geometry, transforms, normals, things like that, just so that we had kind of a good starting point for it. And I should also say, I'll post this in the chat. This is the link to his stream, or to his wiki for the Joy of Vex. And so that's where you can go and kind of follow along with these topics and things like that we're going to be going through. So go there, check it out. His whole wiki is just a great kind of, I guess you could say it's kind of his brain dump kind of different things that he might be learning or going through. And it's been super helpful for me on my Houdini journey now for the past 7-8 years or whatever. If you guys feel like throwing him a little Patreon subscription or whatever, I'm sure he'd be very grateful for that. And on top of that, I believe with the Patreon, you get access to a Discord server that he runs as well, which is super active, and there's lots of good stuff going on there. It's kind of too many Discord servers for me to keep track of and be active on all of them, but it's a really good one, and there's lots of people chatting on there and stuff like that. So I'm pretty sure if you're a Patreon, you can get access to that. So there you go. Yes. Oh, thanks for the follow too. So with all of that said, let's kind of, maybe we'll jump over here and get started in some Houdini, for the evening. So I have my setup a little bit different tonight just so that we can kind of see what we're talking about on the one side here. I just wanted to make sure that we're able to kind of follow along and kind of understand, what I'm looking at versus some of that kind of stuff. Now, the way I go through this is I'm going to try to follow kind of how Matt has this stuff organized, just because I think it's really good. And it's obviously a super effective kind of way to... Hey Jamal, how's it going? Yeah, time difference here and there is 3 a.m. right now. Yeah, sorry it's so late for you, man. This will obviously be on YouTube as well. So I save them all there. So if you want to go back and watch it, if you need to take, get some sleep or whatever, I'm on the East Coast of the US. So for me, it's 8 p.m. I kind of do it in that sense so that maybe I can catch a little bit of Europe, and probably maybe a little, and some of the West Coast where they're not in work still. It's kind of tough, so I'm East Coast time, so of the US. So that's kind of where I'm living, but yeah, it's tough to come up with a good time for everybody. So thanks for joining regardless. So, all right. Yeah. So let's kind of start going through some of these things here. Yeah, you're very welcome. Glad to have you on the stream tonight. Just let me get my stuff set up here. Oh, one more thing before I get too far into this. This was my lovely wife's Christmas gift to me. She gave me a little mug with my stream information on it. So if you've seen any of our prior streams, even from a long time ago, or more recently, I have a little graphic that shows like taking a coffee break, and it has a little cup like that on it. So she made me one for Christmas, which was very, very nice of her. And she snuck into my files and grabbed it. But she's a graphic designer, so she knows what she's looking for. Well, now you can hold this over her head. See, there you go. Now she's got a high bar to kind of clear. So yeah, All right, well, let's jump into this, and we'll kind of get going with talking about some of this Vex stuff here. So here's the file that you can download right here, and it's basically just a GeoNode here with just a GeoNode with a few different geometries going into a switch. If you're not familiar with a switch somehow, this just allows you to select an index here. You can see this kind of highlighted heavy network line that kind of changes depending on which index you've selected. So we can see how we're changing through all these different pieces of geometry here. I'll just zoom out of that. Also, I will set this up, so hopefully you will see what I'm doing now. Yep, there we go. So we can change through the different geometry and see what's going on. We have just a transform node here, which is just going to show us, allow us to translate and move things around, obviously. Normals, we've got some point normals set up here. And that's just pretty straightforward. And then we're going to use this point wrangle here to kind of work on things, as we're going here. So again, this is going to be a little bit basic, just for those of you maybe that are new to working with Vex and things like that. I don't want to just be assuming things for you. So we're going to kind of be basic right now. And by the end of this series, hopefully we should be working in some pretty deep concepts and things like that. Like Theo said earlier, maybe some quaternions and stuff like that. The dark magic of quaternions and the weirdness of four floats and things like that. So why don't we just say Joy of Vex day 1, we'll say like that. We'll just rename it just so I'm a little more clean here. So the one thing that Matt was saying here first is that it's really, really helpful to set up your workspace in a way that's going to be helpful for what you're doing. And in this case, we're going to be working with a lot of attributes and things like that on our geometry. And so we want to see that geometry spreadsheet. If you look here, this is the default build layout that usually is loaded in Houdini by default. If you look here, this is the geometry spreadsheet, and this is going to show you all your attributes, things like that. However, it's nice to be able to kind of see everything all at once. So what you can do is you can use Alt right bracket, and that'll split your view top and bottom. And then you can use Alt 8 to change the bottom one to the geometry spreadsheet. And then once you do this, you go up into the top here and save your current desktop as whatever you might want to name it. Now I have one already saved like that, so I'm just going to pull mine up just so that it's, the one that I'm kind of used to and is just set up the way I like it, however. But yeah, that's basically what we're doing here, just so that we can see our attributes nice and obvious in this geometry spreadsheet. And then we have our geometry up here and parameters and our network. So that's kind of a first step here. But obviously we're here to do Vex, so let's do some Vex. So the first thing that we're going to kind of look at here is doing something really simple like setting the color through Vex, which is a really straightforward thing to do from taking kind of one attribute and setting another attribute equal to it. So the first thing we're going to do here is we're going to look at this CD, which stands for color diffuse. So we're looking at the diffuse color of an object, basically. So it's display color, basically. So what we're going to do is we're going to say at CD, and it's got to be a lowercase d, and we're going to say it's equal to n. And so the reason we're able to do this in this case is that we've set this normal attribute in this node here, so that gives us this n attribute. You can see that here as well. We have a vector that's n, and we're going to set CD equal to it. So once we do that, we can see that CD is equal to n. And the thing to think about here is that you've got these two vectors, right? And we're taking this normal, which in this case are normals. If we turn on our normal display right here, they're all pointing up, right? So a normal is 3 floats and color is 3 floats, right? And so what we're doing here is we're taking our normal vector here, which is 0, 1, 0, and we're setting the color to it, which if we think about it is now 0, 1, 0. But because green is the middle component of that vector, everything's green. So in this case, not super exciting, but we can go to something like the sphere. We can see that we're getting all different colors based on the direction that those vectors are pointing, right? Same thing's going to happen with something like our pig head here. So there's our pig head. And in that case, obviously we're getting a lot of different colors and things like that. If we want to turn off this this UV grid. This is something that's a little bit newer, so might not be in some of the older versions, but that we can turn off and we can now see those normals visualized there. And then if we get into something even more complicated like Tommy, we can see all these little nuances and things like that of color. And you can see that depending on which direction he's facing, it's going to be, or these normals are facing, it's going to be more or less red, green, or blue, depending on those colors. And you can see kind of here too that these colors now on this kind of resemble the colors of a normal map. If you've ever seen like a an image of a color map, of a normal map, these basically feel the same because you're saying what directions are the normals facing, and so you kind of get this range of colors that kind of live in this whole kind of bluish, greenish, kind of world, and it gets pink and red and stuff like that. So that's what we're seeing here, and that's why we're seeing those values the way they are. So let's all right, so let's do that first. And then now instead of doing n, let's just change this here to p. And this is going to give us a slightly different value here, basically. And what this is doing, obviously, is taking the position and the value of the position here, which is, in this case, for point 0 is 0, 0, -4, and setting the color to that. So we're at that point, it would be completely blue. In fact, it's over blue, right? It's way under blue, I guess, in this case, because it's -4. So there's some weird values now that are inherently going to get written here. So it's not exactly going to, be valid color data because they're kind of these weird negatives and things like that. But we're starting to see how we can visualize these colors and look at them. And you can see here that obviously they're all centered kind of around the origin. If we change it to the grid, that might be a little bit easier to see as we go in these different directions. There's going to be blue, red, kind of a combination of blue and red. Obviously, we don't have any green here because nothing is going up. So we're only combining blue and red. So we're getting these kind of all starting from the origin and going from there, and obviously going past into the negatives, we get these over darks, which happens pretty quickly, obviously, since we go right from 0 into the negatives, and then it's basically past black. So just a couple things to think about here is that if we take this and we do some transforms and things like that, like we're talking about here, say we do like a rotate or something, the geometry is going to move, but the color is staying the same in this case because it's based on P. So just based on whatever point positions these are in, they're going to keep kind of relatively, visually in the viewport in the same area. Those points are going to get those same values since we're talking about kind of the world space of it. However, let me just reset that here. However, if we take we'll go back here and let's change this to n, for example. Now in this case, they should stay relatively the same. Let's just move this around a little bit here, right? So we're getting relatively the same look here, but it's based on the direction that they're pointing in, right? And the other thing too to kind of keep an eye on is like, so for this, for this pig here, for example, if we take this and rotate it, right, it's going to have a little bit of a different look than just that sphere. This actually keeps some of that interesting, some of these shading details kind of stay as you rotate it around. However, the colors are more or less kind of staying in the same space just based on what directions they're pointing in and stuff like that. So a little bit of a different look for those two. Again, if we change this back to P, this might seem like it's kind of staying, the colors are staying a little bit more stationary just because you're seeing less of those like individual details going on there. So they kind of stay in their same little quadrants as we rotate around and things like that. So that's kind of the first thing to understand here. And the color is a great way to visualize things in Vex, obviously, because we can see that in the viewport real easily. Now there's ways to visualize things in the viewport, and we'll get to that in coming lessons and things like that. But for right now, color is a great way to kind of visualize that. It's also just a really basic attribute that'll stay with our geometry as we go. So let me just reset this here. Kind of back to normal there, everything. I'm just doing control and middle click, and that's resets your parameters here. All right, so let's now look at how we could set things just to a float. Now, in this case, we're talking about CD, which is a vector, and P, which is a vector. But let's kind of move into setting this to something that's a float instead of a vector, just one float instead of 3. So let's do p.x for this case. And we'll do that. And now we're evaluating this based on just this individual component of P, just the X component. So what we can see if we look at our geometry spreadsheet down here is that our color is being set to only the X of our position. So our x is -5. So all three values of our color is going to be -5, 0.55, -0.55, -0.55. So in this case, we're looking at just one float component of the position, not all three. So a vector in this case is taking three floats together, and we can pull out those individual subcomponents and use those by themselves. So in this case, we're setting CD to p.x. Now let's do something else, like in this case, we say n.y, right? So we can do this, and now we can kind of see this. We're setting it to the y component of that normal, right? So we set all these normals here, right? And so we're only taking the y component and shading by that. And this is really similar to actually some of the mask by feature things that you can see in normal in a SOP. I believe it's mask by feature is the name of the SOP. And it does something similar to this, where it's actually going to kind of color a mask based on the direction of the vector, basically, of the normal. And so in this case, we're getting kind of this interesting shadowing from it because it's setting it based on how much y up is in that vector. So in this case, this one is going to be a negative y component, and so these are all going to be negative. But then down here, this one has a very positive y component, 4.4, and so in that case, we're going to get maybe about halfway white, about 0.4, and so they're going to be varying levels of white. So these points way up at the top here. So like if we select a couple of these here, let's go into selection, and we'll go into sorry, that's the wrong one. 2 is what we wanted. I'm just going to select a couple points up here. I'm just going to say show only selected. And so these should all be very, very white, basically. You can see a lot of these are up in the ones as far as their Y component. And so therefore the color of them is very white. Some of them are more of a mid-gray, but actually that's because I selected some through. That's why. So if I only selected visible ones, these are all going to be basically all white up at the top here. None of them are going to go even below 0.9. They're all above 0.9. So all of these are getting that white attribute. So that's how we're getting these individual components here from our normal attributes. I'm going to set this back to show only selected. So that's a way that you can obviously take just one component and set it the whole vector to just that one component. So these are pretty straightforward things. We're kind of just going to build on top of these ideas here. But that's kind of where we start, where we're setting attributes, kind of maybe from other attributes or doing some math to an attribute and setting, something like our color from a bunch of math that we might be doing. So what this next kind of paragraph and section is going to be talking about is doing basic math to just one of the components in your geometry or in your attribute that you're pulling from your geometry. So I'm going to go back to the grid here. And I think this will kind of visualize this best so that we're not maybe overthinking this while we're looking at all this complicated geometry and stuff like that. We can just kind of look at a flat grid and see what's happening there. So the first thing we're going to do is, instead of setting it to the n.y, let's change it back to p.x. We'll do that, right? So here again, we can see that we just have this is like super basic visualization of it, right? It's just a 2D visualization of it. And we're saying basically starting from the 0 origin point here, as we go to the right, which is positive, it's going to get more and more white, which at a certain point is over white and is just kind of in the, +5 in this, over at the far end here. And then over at the bottom end here, there's going to be a -5. So this way we can kind of see exactly where our center point is and kind of how these values are really looking. So then we can do things, just simple things like adding 3 to this, right? And now that's going to push kind of that center point that we're evaluating to the left into the kind of into the negatives now. So now we have a lot more white in here because now we're saying the color is equal to p.x plus 3. So we've added 3 onto that value. So all of these negatives are now going to start rolling into the positives, right? So we can see that now quite a few that were negative before are now going to start being positive. So we can do that. We can also take this and change it to something like, -6. In this case, obviously it's all going to be black now, right? So that's maybe not exactly what you would want to do in this case. Maybe, oh, maybe that's too much or whatever. So then we could do a scale on it, which is something like 0.1. So in this case now we're subtracting 6, but then scaling it based on a value. So so that's something that we can do. And you can also, with this basic math, you can do things like use brackets here, right? So in this case, we're going to say that we want to make sure we do p.x minus 6 first. We don't want that to be evaluated based on the order of operations in regular math, which says that, the multiplication, division, addition, subtraction, how those all order, and exponents and all that kind of stuff. We're going to use the brackets to kind of group those together and make sure that operates first. So first we're going to do p.x minus 6 and multiply that times 0.1, or we could also do something like 0.3 in this case. And so you can see that these values are still changing. However, it's tough to visualize them because they're now all pretty much underneath 0 for black. So in this case, we're, just kind of seeing how we can group these things together in a way to be able to manipulate these values as we go along. So obviously very basic stuff here, but we're just trying to build on kind of the syntaxes that we're going to need to use. Another thing you'll notice is that I always have a semicolon at the end of a line. That is like number one thing that you're going to mess up at some point is forget to put a semicolon, and it's going to throw a big red error at you. In fact, I'll just do it right now, and it's just going to get angry and nothing's going to happen. And, if this is in the midst of, 20 lines of code, you might miss it and have to take a few minutes to go back and find it. So just if you're ever getting errors, semicolons are a pretty good spot to look first to make sure that each of your lines end in a semicolon. So, yeah, so hopefully that's all pretty straightforward. One thing I do kind of want to say as well here is that as I'm going through this stuff, please, if you have any questions or suggestions or thoughts, drop them in the chat. I always like for this to be a bit of a back and forth. This is a little bit of a different path for me to take with, taking some pre-made content and kind of, streaming about it and kind of following it. So, I'd love to hear anything you guys are thinking about it. If it's, if you're seeing something that's a question or you're not understanding something, or maybe I jumped past something a little too quick, you can always, let me know in the chat. I'd love to hear any and all comments. Yeah, hopefully you're finding this helpful so far and understanding some of the basics of Vex. And at very least, it's just a good refresher if you're somewhat familiar. So, yeah, so if you guys have any suggestions, please feel free to drop it into the chat. Or just comments at all, totally cool with that too. So, okay. So we've talked about kind of some of the math ideas here. We've talked about setting attributes based on, vector to vector, or maybe something like a float subcomponent to another, to a vector. Now what we're going to look at is kind of individually assigning these attributes, right? So in this case, we have something like CD, right? But let's say we only wanted to change one part of that and not all three of the vectors to the same thing. Well, just like with this p.x that we have here, we can say cd.x. And here, I'm just going to kind of copy his code so that we can kind of follow along a little bit better here. So we're just going to match this and say like that. And so now what we're doing is we're setting just the x value of the color to this attribute, this string of math basically. So we're subtracting 3 from from the x subcomponent of position, and then multiplying it by 1.2. And so that's like, usually when you take a multiplier like that, it's usually some sort of a scaling factor that you want to do to it. So maybe we want to make sure we can scale it by 1.2. Now in this case, we could also do 0.3 and make the scale smaller, or we could make this way bigger and go up to say something like 3. And we'll see that these scales kind of change and adjust how these values are mapped across the geometry. I'll go back to 1.2 just since that's what's in this here. So, okay, so we're just going to go through and do the exact same thing to all of these. So we're going to say at cd.y equals, in this case, we're going to look at, I'm going to match his code here and just make sure we're kind of following along as best we can. So he didn't have brackets on that, so we'll just change that. So now we're going to do at p.y, and we're going to say plus 2. And again, semicolon. And then the last one is at cd.z equals at p.y. Oh, yep, sorry, I had those backwards. I'm not reading properly. There we go. So we have these kind of three different values that are being written here, right? And we're using different elements of position to set those. So now we're getting kind of different colors than if we would have set it based on just this standard XYZ. In fact, you can see now that our Y is being affected by the Z. So as it goes in the Z axis, we're getting more color more green color based on that. And the Z, really, there is no blue being represented in here in RGB color mixing. So then again, we can take this and, transform it around, and these values will all kind of depend on that. So we could take these and we could change this to maybe say 1, or this one we could say maybe, let's try 1 on that too. There you go. So something like that. Or we could say, -1, and that will, sorry. The thing that I actually am really bad at remembering is that Control-Enter will evaluate your Vex code. I usually just click off of it, which is a terrible habit. I guess nobody had ever told me that before. Honestly, before I started looking at Matt's stuff. So, shame on me for not knowing that. But anyways, yeah, so basically we can take these different numbers and use them as offsets for our geometry. Where the kind of the 0 point is of this, that this is being evaluated from. Because as you add or subtract one from these different subcomponents of the position, it's going to kind of change where it's starting that color ramping kind of from. So, okay. So we've talked about obviously using position to set color and all that stuff. So that's cool. But obviously there's a lot more things that we could use here to set, using different elements and yeah, see, there you go. I never knew that shortcut either. But let's talk about something maybe a little bit different. And this is one of those kind of not intrinsic. I don't want to say that because there are things called intrinsics, but these are one of the built-in attributes for Vex, and that is the PT_num attribute. And so we're going to be looking at that, and basically that's saying point number. So I'm just going to get rid of all this stuff here. We're going to go back to just CD, and we're going to say that CD is equal to and at PT_num with a semicolon here. And so what that is going to do now is set the color equal to the point number. Okay, so when we look at our geometry spreadsheet and we're in the point mode here, we can see that each of these points have a number, right? And in this case, we're going all the way up to 899, right? So from 0 to 899. And each of these now are going to have our color set by that. So the first point is set to 0. And if we turn on our point numbers here, we can look and see. So this one way up in the corner here is black. And you can see there's just a sliver of black there, right? So that's the only one that's actually getting any type of, interesting color value. The rest of them are just all past 1. So they're all way more than white in this case. So we need to do something to kind of fix that, right? That's obviously not going to look interesting. So we want it to kind of go from maybe something like 0 to 1 so that we get a color ramp across all of these points. And so what this next step here kind of is saying, what this next code is looking at is saying, okay, let's take the point number and divide it by the number of points, which again, we have another attribute that's kind of built in that's called numpt. And that one gives us the number of points in our geometry that's coming into this wrangle. So let's just do this here. We'll do PT number divided by numpt, which seems kind of like this weird, like almost like palindrome there. But now nothing happened. Everything got crazy. If we look here, now all of our values are at 0 somehow. Like that's kind of weird, right? Like that doesn't seem to make sense. Like it should have worked. But the reason that doesn't work is something that will kind of bite you from time to time if you're working in Vex. And that is the idea of, taking an attribute that's something like an integer, which point number and numpt both are, and trying to do something like a division with them, right? Because they don't have a fractional component to them. So you in that math, you can't actually do a division there because it doesn't know what to do. It kind of is just like, well, I can't, these are two integers, so we're just going to say 0, I guess. And everything just pretty much gets 0. I'm not sure if the last one Hey, Zach. Welcome to the stream. Yeah, Happy New Year, man. Um, yeah, so all of them got black. Not even like the top one didn't like the very highest one didn't like round up to one. It wasn't doing any weird rounding or anything like that. They're all getting zero because we don't have this idea of the float with the decimal point with the fractional amount in there so that it can do those in between values. So the way that you can do that is by doing a cast. So in this case, we're going to say float. We're going to do a open bracket and then a close bracket here. So we're going to enclose point number in a cast to float. And so now in this case, we should have it so that they all are now actually giving us some output from that. And we can see here we're up in the 0.9799 all the way up to like 99 whatever high number there. And then if we go down the other side, we're at zero here. So as these go up, we're going to see that these values are going to change. Maybe a little hard to see that, but this is zero over here and this is 29. So as it goes from 0 to 29, it's going to go up to, it's going to go up to, let's see, where's 29 here? So up to about, 0.03, and then it just keeps going. They keep going up, up, up. It looks pretty smooth, but if you were to maybe change the scale of this, you would see some more stepping in there. But this is kind of a way that you can take your values, right? This is a really common thing to do, is take something like the number of points versus, maybe some value that's coming in and divide it. You could also do the number of primitives, things like that. There's a bunch of these that are built into Vex. So it's kind of a nice, quick shorthand way of being able to get some things from your geometry that you're bringing into it for free, things like attributes that are already kind of there by default. Another thing I should say is that this right now is operating over just the points, right? So that's one thing just to keep in mind here, is that these are just running over the points. So every point, it's kind of working over each and every point. And we're going to kind of get into this idea, I think, a little bit more as we go through this series. But each of these wrangles is kind of its own little iteration over everything that's coming into it, right? So it's a way to be able to do something for each individual point, right? So each point is bringing this value in here, this PT num value. So in one of these cases like this, we're getting 10 here, right? And so we're taking 10 and dividing it by the number of points. And so we're doing 10 divided by 900 because there's 900 points here. So it's taking that and dividing it, right? So that's how we're getting these values back. So this PT num is changing every single time that this evaluates, right? And num PT stays the same because it's just globally the number of points that are coming in to this first input here. And I should say that too. We'll get into more on maybe some of these other inputs as we go on, but right now we're just looking at input one here. Okay, so the next thing to do, we could just for example, that num PT can be replaced with anything. We could replace that, say, with 100, and that's going to change it so that now by 100, we should be at 1. In fact, there we go. There's 100. If we're dividing 100 by 100, that's 1. And there's our value of 1. And then everything from there is going to be past 1. So it's going to be kind of in this over bright color, but we still can only visualize it as white. So there we go. That kind of gets us thinking about some of these different attributes that exist in a wrangle that we can kind of call whenever we want to. Again, some of these things we have to cast to a float in this case, meaning, float being a number with a decimal. If you've come from other places, there's different names for what that sometimes is referred to as. Some like for me, I learned cinema originally, and they would call floats real numbers or reals in their like espresso setups and things like that. So there's different names for these things, but in here we're calling it a float. It's basically a decimal, and an integer is just any whole number basically, without any decimal places. So, okay, so we've got that down. We're starting to talk about some attributes here. We're talking about components of vectors, things like that. Now let's get to something that I think is where wrangles start to really get exciting is setting up things like channels. This is a really cool thing because it's something that you get to control as you're working in here, right? So in this case, we're just looking at this GIF here, right? Instead of going in and typing different values here, like, oh, I want this to be at 10. Okay, it's just this little bit. Oh no, instead I want it to be at 750, not 7,000, 750, like that. Okay, now it's ramping between 0 and 750. Well, if you want to be able to control that on the fly, it's kind of annoying to have to go in there and type in that value all the time. So it'd be great if there's a way to do that quickly. And there is. It's called a channel. And so let's take this and change it into a channel. Oh, sorry. Just CH. I don't know why I typed channel. I know how to do that. Okay, so what we're going to do is type in CH. And one thing to note in Vex is that if you type in a function and just stop at the open bracket, it'll pop up this little kind of help sheet here, which gives you some of the help documentation, but just in a way that you can quickly look at it. So in this case, it's going to talk about, CH, which is just evaluates a channel or parameter on a node and returns that value. So in this case, we're just going to use CH, but you can see down at the bottom, there's quite a few different ones here. There's CHF, CHS, CHI, CHV, blah, blah, blah. There's lots of different ones, right? And there's even CH ramp, which is a really fun one to use as well. But for this right now, we're just going to use CH, and by default, that's going to make just a float for us. So let's do CH, and we'll type in scale here, and we'll put that in parentheses, which is important because it needs to be a string attribute. Parentheses are going to, quotes are going to denote strings in Vex. So there we go. We've got a string in there, and now we can hit. We can hit Control Enter, and nothing happens because that channel or that parameter doesn't exist yet. So in order to create it, we use this nice little button here and click on that. And now we have a scale parameter down at the bottom here that we can animate and work through, right? So we can say, okay, it's 0.1, and we can go back and forth between the float. That's really weird. Why is that looking like that? That does not seem right. Oh, right. That's why. Because we want to go higher. Because we're doing this, the point number divided by a certain number. I was thinking we wanted to go to 1. But we wanted to go to something like 100, for say. Okay, sorry. I got a little confused there for a second. Okay, so in this case, now we can take this and we can use our little middle click to bring up this ladder and kind of shift back and forth based on how big we want it to change, right? We can change it by tens, hundreds, all that kind of stuff. So this gives us a way to be able to really quickly adjust these bigger numbers. Thank you. Thanks, Matt. Yes, bigger numbers. You always gotta get those big numbers in there. So this is a way that you can go in and change these values on the fly kind of as you want to affect maybe something that you're working on your geometry. You make an effect, you want to be able to art direct it and make it look the way you want it to. These parameters are really what are going to help build that as you go along working in Vex. One thing that Matt noted here is that the scale is by default 0 to 1. So that's why when you only slide this up, you only get to 1. You don't get past it. So again, like he said, you got to go into the big numbers and get some real stuff going on here. And that's because we have, almost 1,000 points. So in order to get those into reasonable values, you have to divide by a relatively large number. Okay, so we've got channels now to work with, which is a really cool thing. And that's something that we're able to work with pretty quickly. And it's basically just a quick little line here with a string in here. You can see that scale is the name of it. And that was because that's the string that I put in here. And so it made the name of this parameter scale. But let's now talk about a different function, something that's maybe we can do something with. And that one is sine. We'll talk about sine first because this is a pretty straightforward, math function. If you've done anything in your algebra classes or whatever in school, you're probably pretty used to seeing sine at least. Maybe if you're really afraid of working with math, this seems like a really scary idea, but It's actually nothing too scary to just think about conceptually. Basically, you're looking at just, it's almost like if you've ever seen one of those old fashioned oscilloscopes, right? You just see those kind of waves going up and down. You've got just this little kind of up and down crest and peak, trough peak kind of wave going back and forth, oscillating between -1 and 1. So it's kind of oscillating around 0 based on the number of, the number that you put into it. So in this case, we're putting in the number point number, the current point number into it. And then in this example, we can divide it by 100. And now we can see that this is now oscillating back and forth. Here, the sine is oscillating between 0 and 1 over a, kind of a broad range here. You can see it's kind of these long swaths that are getting these colors. And we can look here and see the attributes are going from 0, maybe to 0.8, and then down up to 0.9, 0.1. So now it's coming back down, -7, -9, and then the next one's -2. And so these kind of oscillate back and forth, right? So they're going back and forth on this kind of roller coaster hill type thing where we're going up and down based on what number you're putting in inside of that function. So for a sine, all it's really looking for is, in fact, let's just go back here and I'll just put in the first open bracket here. So it's just looking for a float. You can see that right here. In this case, we're looking for a vector, because we're outputting this as CD, which is a vector. So we're doing the sine of the vector. But in this case, we're just looking at one individual float, and then that's being written to all of those vector components, right? So what we were doing there was we're just looking at each individual point number. And as that goes to this pi times 2 units, which obviously pi is 3.14, blah, blah, blah. As it goes that times 2, every time that happens, it goes to its next, kind of to the next repetition of that waveform, right? So that is kind of how that goes along. So we have sine, we've got sine, and again, we had it at pt num divided by 100. Cool. So there we go. There we're back to just what we were visualizing before. And you can see that as I was typing in there, it wasn't updating my viewport, right? It was just leaving it as it was. If you were to do something like, like this and then control enter, it's going to freak out. But if you're just typing in there, it won't kind of keep updating every time you type a letter or whatever. So just something to keep in mind. All right. So here's another thing that we're dealing with now. Again, we're dealing with that same integer problem, right? Because that's why we're getting these like kind of big chunks here. We're not actually working with floats. We're working with whole, integers. So let's do this. We'll do float, and we'll cast this point number to a float, just like this. And so now it's going to smooth it all out, right? So now these values are nice and smooth. They're not getting these big chunks anymore because each of those, that kind of point number is now allowing that decimal to be included in that math. So now we're not getting these big chunks, but just now we're getting kind of this nice smooth function that we're seeing. And so it's going here, you can, if you think about it, we're kind of seeing it from this one angle where it's kind of going up and down. This is going to be the peaks here. These are going to be the valleys, and it's going to be going peak, valley, peak, like that back and forth, right? So now we have that cast like into a float. And what we need to do now, what we can do from here is we can art direct that using that same scale concept, right? So if we take this just in this next line here, so we have our float pt num, and instead of doing it by 100, we'll do the same thing, and we'll take ch, and then we'll make sure we have the right number of parentheses, put in our little quotes, and say scale again. And since scale exists here already, it's going to see that, right? And so now we can play with this and really kind of go for, different types of noise and things like that. So we can get these different patterns, like crazy patterns from just this one node, and coloring it based on those values. So now we can get some pretty interesting looking results just from one line of code, right? But the thing that you're kind of seeing here, which it can be a little tricky to deal with when you're coming in maybe to somebody else's project, is that we're starting to get a lot of things kind of packed into one line, right? So a better way of doing this is maybe splitting it up into 2 lines, right? So instead of this whole thing happening here, let's just kind of play with this a little bit. So what we're going to do is we're going to say float we'll say foo equals, and we'll say float. Oops, sorry. Float. And again, we're casting point number to that. So we'll say pt num. So we're going to take this whole second line here and kind of bring it up. And we'll say ch, oops, sorry. And then scale like that. Okay. So now we don't need this down here. We can kind of clean this up a little bit. And what we're going to say is we're going to delete this from in here. And instead, we're going to say foo, because foo now contains this line. And so if we hit enter here, we can see that I definitely typed something wrong here. And what did I type wrong? I think I had 2 parentheses there, possibly. Yep, that's the problem. There we go. Again, always a little something in there can trip you up. So, you know, these are things you're going to have to kind of get used to, is seeing your code and trying to debug it quickly and see what maybe is the issue. In this case, there's some highlighting that'll happen in your little Vex text box there, so you can kind of see what's happening. And I saw there's a little underline there, so it's probably saying that was the wrong thing. Another thing that's nice too is that you can kind of see which is the parentheses that kind of goes along with this. And you can see it's kind of highlighted there. It might be hard to see on the stream, but as you play around with it, you'll see that. So anyways, now we have the exact same thing as we did before, but it's a little bit cleaner because now we can see that this foo is storing all of this information. And then we can see that, oh, we're using that foo float value with a sine function and writing that to CD. So this is something really powerful, again, that kind of builds off of the idea of kind of attributes that are stored on geometry, except in this case, they're called variables, right? So whenever we set this at here, and I'll just slide down here so we can kind of see what we're talking about here, the section we're in. So whenever we write something like this at CD, that's saying that we want to save that as an attribute named CD. In this case, CD didn't exist before this, and so we're making a new attribute. You could write over attributes that do already exist with things like this. However, when we say something like this, float foo, what we're saying is we want to create a float variable. And variables are really kind of like helpers. Like they are things that live only within this attribute wrangle. They don't get saved downstream. In fact, you can see foo doesn't exist over here. We don't have an attribute named foo. We only have foo as a variable that we can call. And foo, we don't have to put an at in front of it. We can just call that just as its name, just like that, foo. And so it's a really helpful way to kind of organize your data in your wrangles. You can create these little helper values, whether it's a float or an integer or a vector. There's other attributes, strings, things like that. But that's a really helpful way to kind of consolidate what you're doing within one node and kind of keep that data available in that one wrangle versus trying to save everything out as attributes, because whether you realize it or not, every attribute you have on your geometry is actually going to make saving that file bigger. So it's not always a great idea to just dump all your attributes into your geometry, because when you get to saving it to disk, especially if you're saving a huge amount of points, primitives, whatever might be holding these these attributes, you're going to have a lot more data to store. So that's why a lot of times, as you're learning Houdini, you're like, or any software for that matter, but Houdini in particular, where you can make all these attributes, you get to a point where you're about to cache out your data and you're like, man, that's a huge cache. It doesn't seem like it should be. Well, maybe there's 40 attributes on those point positions or on those points and all these different, things that you're saving. That just takes up space. So in this case, we don't need to save that foo attribute. It's just helping us kind of clean up our code. So something to keep in mind as you're kind of writing Vex code here. Just some really nice little concise ways of saying it. Variables are temp throwaway data that only exists within the wrangle code, and attributes are data that's on the geometry, that's saved on the geometry. So those are kind of two very different use cases for those two different things, but they're super powerful in their own way. So something to keep in mind. All right, so yeah, so we were originally, we were looking at this based on point number, but if we wanted to change this and say drive it by their X position, we could change to this code here. So instead of float point number, we can just say at p.x, right? Sorry, that little thing is actually saving what I typed in there. All right, so we've got our float p.x, right? However, if you read this little paragraph down here, it's saying, well, we already know that p.x is a float. So we really don't need to cast it anymore. There's no real reason to. So knowing kind of what type of data your attributes are bringing in is helpful. We know that a one component or a subcomponent of a vector is going to be a float. So in this case, we can just get rid of this float. We don't need it to be here. And it's just going to clean up our code, make it look nicer. So, what Matt says here, clean code equals good code. Totally true. The easier you can read something, the better it's going to be for you. And the better it's going to be if you have to pass it off to anybody else. That's especially that, because if you try to open up someone else's code and it's not laid out well and set up well, and it's not commented at all, which we'll get to in a little bit, that can be just a total pain to try to figure out. So you're being nice to your future self when you open up a document and you're trying to read through something that you did maybe 6 months ago, a year ago, but you're also doing something nice to other people too. So, be nice to yourself, be nice to others. Nice, clean code. So yeah, so there we are. That's basically the end of the first section of the Joy of Vex. And the thing that I want to kind of do as we go through this is there's some exercises that are put here, saying something like, can you make sine waves on Z or on Y? What about cosine waves? Not going to look hugely different. It's just shifted by a quarter of a wave, the wavelength. What about wave based on the components of N, or, tight sine waves on red and cosines on blue, a wide ramp on green. So all these different kind of exercises that you can go through and do. So if you're a part of the Discord, server, I would recommend you going through some of these exercises. Check this out on your, whenever you get a minute. It shouldn't take too long to try to work through some of these things, especially based on what we talked about here. And then maybe post them, in the work in progress section, or, somewhere where, you can talk about it and be like, oh, I think I got this. Or if you're having trouble with a certain thing, hey, what's going on with this here? And we can kind of talk about what, why it's working, why it isn't working, that kind of thing. So, that's what I'm going to encourage you to do throughout all of this. If this is something that's new to you, go in and play with these different exercises and start to see how you can do these on your own, because going along with this is going to be great, but really going and doing it on your own with having to type in the code yourself and kind of understand what you're typing is going to really be the thing that locks it in. You can follow all of the tutorials that you want to in the world, but unless you're actually doing something that's a variation on that, or a derivation from that, you're never really going to understand what you're doing. So that's just something I think overall is a good thing to know. But okay, so the one last thing here that I really like to think about with something like this attribute wrangle is that it's doing a really elegant thing here. And I think this is really one of the powers of Houdini that a lot of times you just kind of take for granted. And that's the idea that this is iterating over every point in your geometry, right? In this case, we're talking about, a few dozen or a few hundred points. It's not anything crazy, but you could get into the, 100,000 million points in using wrangles. And because of the optimizations that are built into this, it's able to iterate through all of those points super quickly. It's basically what he kind of walks through the whole thing here. Most other languages, you have to iterate through the points, create the CD attribute, allocate memory, update that color, and then probably have to think of your own ways to get performance out of that and make it better, or just say, well, it's slow, whatever. But Vex is actually doing that for you, which is amazing. And, knowing and listening to the mathematicians at Side Effects talk about the stuff that they do, it's kind of amazing to see how, their brains make it into these nodes and things like that. So it's definitely a real, it's a really amazing way to be able to work with stuff. On the next point, though, it can be very unforgiving. And like I said, you put a parenthesis in the wrong place there and it just goes, nope, sorry. So that is definitely something that can be really scary when you make one little mistake and it goes, whoop, nope, you lose. Everything's bad, error, and you don't always know how to fix it. So, I mean, there are, plenty of people that are, seasoned veterans in working with coding and programming and all that kind of stuff. And they'll, even them, they'll put a little syntax error in there, a comma or parenthesis in the wrong point, or use a comma instead of a semicolon in a certain place, and it'll freak everything out. So those debugging techniques are definitely a thing that you have to learn as well, and ways to kind of troubleshoot what's going on. And it's a learned thing. It's not something that happens within, some, immediate, one day thing, but just something to keep in mind that debugging is something that you kind of get used to. It sounds scary, but really it's just looking at your code and saying, what's actually could be going wrong here? What am I seeing? Maybe is there an obvious syntax thing that I'm missing or whatever? So, and also Matt mentions at the end there that it's, these things are a couple lines long. You usually aren't writing huge, 150 line code blocks in an attribute wrangle. In fact, I might even say that if you are doing that, you probably should be splitting it up into several wrangles, because there's usually not a great reason to do everything all in one unless you're doing some, I don't know, maybe some incredibly complicated thing. But I mean, a lot of what you can do in, up to 20 lines it's pretty amazing, the stuff that can be done. So just keep that in mind as you're kind of working in Vex or starting to get in there. You're not going to have to be doing, essays of Vex code. So cool. We made it through day one, or lesson one, whatever you want to say. And I think we're going to go on into lesson two. That took us maybe about 45 minutes. That's pretty good. So yeah, let's go into to lesson two here, and we're going to start talking about some more functions. We'll see how far we get. Maybe we'll get to 3, depending on how we're all feeling. Everybody feeling good? Any questions out there in the audience? Anybody awake? Anybody asleep? Whatever. Hopefully everybody's doing good. So if you do have any questions, drop them in chat. Everybody can have it set up so that everybody from YouTube can see Twitch and vice versa. So if you have any questions, people will be able to kind of follow along with that. Full of joy. Yes, good. Do I ever use the other wrangles? Well, sure, yes. In this case, we're just using, technically they're all the same, right? An attribute wrangle is all of them. So like if I put down a point wrangle, it is just naming it point wrangle. It is still an attribute wrangle. You can see the type right here is attribute wrangle. So all of these, regardless of what they are all the same type of node by default. It just depends on what this run over is set to. So for example, if I do a prim wrangle, that is just going to run it over the primitives. Okay. So really, yes, you do. I mean, the other, if you just type in wrangle here, right? There are some other wrangles that exist beyond just the attribute point primitive vertex. But like height field wrangle, rig attribute wrangle, deformation wrangle. Those you can use, and they're a volume wrangle. I use that a lot if I'm working with volumes, but they're all conceptually the same. There's some slight differences in them and how they deal with the data and how you bring them in and out. But yes, I use the other wrangles, but all of the basic geometry wrangles are the same attribute wrangle. And so you could always change it just on the fly. You can change it from primitives to points, numbers. You can just do a certain number of times it runs through it. You can do it over the vertices, or a really interesting one that I'm sure we'll get to at some point in this. I haven't looked through every one of these lessons, but the detail one just runs it once, and it works off of detail attributes, but it also doesn't have the, kind of the sometimes problem of having it iterate over every single point or primitive or whatever. Sometimes you just want your wrangle to run once, and so the detail is for that as well. So so there are all the different wrangles. So all right, so hopefully that answers your question, KG. Sorry, usually I have the chat above my head here, but it does not seem to be showing up today, which is very odd. So I'm gonna have to see why it's doing that, because that is really strange. Must just be an error with how I have this set up. So my apologies that you guys can't see the chat on the stream, but hopefully I'll have that fixed for next week. All right, cool. Any other questions? I'm gonna head over to kind of day lesson 2. Cool. Yeah. Awesome, man. Got it. Thanks. Yes. Cool. All right. So in this one, we're going to talk about some functions, right? There's 3 different functions we're going to talk about today. In this one, or in this section, I should say, not today. But before we get into that, let's just do this. We'll click on this guy and we'll see maybe the scariness of all of the Vex functions. Can I change this without changing both of them? Sure can. There we go. All right. I'll set this a little bigger. So there is a whole part of the documentation for the Vex functions, and there are a lot of them. I'm just going to click my mouse and scroll down here. It's sort of terrifying to look through them all. I know. But the good news is you don't have to memorize them all. And a lot of them are just for USD. So, which is actually really neat that there's USD ones. I'm not even gonna get into that, but yeah. Anyways, so there's a ton of stuff in here, right? There's a ton of functions. It's kind of overwhelming. You don't have to memorize them all. That's not how you do this. That's not how you do Vex. I mean, the really nice thing is you can filter through these here. So if you need to do something like understand, like something like some sort of find, you're like, oh, I want to find an attribute or something. Okay, find attribute value, PC. Okay, there's different find. It'll kind of help you filter by certain things here. So, just keep that in mind that there's ways you can sort through these. You don't have to take them all as one big chunk and just try to digest all the functions of Vex. I hope nobody has them all memorized. That seems like a terrifying mind to live inside of, to know all of those functions. But I'm sure there's some people that might know them all, but that's not me. Anyways, so we're going to start with a simple one first, though. We're going to start with length. So I'm just making a second one here, just so that we can work off of this and we can kind of keep them all separate. You can do it however you'd like to. If you're following along, do it however you feel comfortable. I'm just going to do it this way for right now. Maybe every stream I might do, add in some more, maybe make a new file and have just those ones for that stream. But anyways, this way we can kind of keep them separate and reference back into them. So, okay, so we've got this, and we want to say, we want to use the length, right? So we're gonna write this value right here. So we're gonna create a variable called d. So we're gonna say float d equals length at p. All right, so let's just break down what this is doing, right? So this is basically saying we want to set this float value of d, this float variable, to the length that the point position is from the origin, right? So that's when you're talking about the position, its vector length is its distance to the origin, right? So, okay, so we've got that. Didn't do anything. We don't have any attributes or anything visualized here, but we know that it should have created D because it hasn't given us any errors here, and everything seems to be working just fine. So let's go to the next step and set that to color. So we'll do @cd equals D. All right, so now we're getting somewhere, right? So now that ramp kind of fall off ramp, whatever you want to call it, is being centered around the origin, right? You can see where these origin lines are coming in here, and we have 0, 0, 0 is right there. And so this is going from black at the absolute origin, which there's no point there, so that value is kind of a little bit gray because we don't have a specific point right at the origin. But those are all getting to be pretty low here. I'm going to sort this so I can see what our lowest value is here. So 0.24 is the lowest value. Okay, cool. So we've got that. We've got the distance, float D. I'm just kind of thinking that is the variable kind of short for distance. D is for distance. And so, okay, that's cool. But now let's take that sine function that we worked on before and use that as well. So we're just going to take sine. We're going to say sine of D. And there we go. Now we're starting to get something happening, right? So now let's take this scale value and add that in there. And so what we're going to do is we're going to take D and multiply it by the scale. And so you could think, okay, well, we already called D, so then we have to say D equals D times scale, CH scale. That seems kind of like a weird line, but you can actually do this really nice little shorthand here, which is times equals, and then we can write CH scale like this. And this times equal is going to say D multiplied is equal to being multiplied by this scale, basically. And so now we can reset these values and need them a little bit bigger. Sure enough, we're starting to get some rings happening here, right? So, and just like it's showing here, we use that little ladder, and we can make that, you know, ring change based on the scaling that we're adding to that distance, right? So as we're changing what that D variable is being calculated at, it's actually changing how the sine function is evaluating, right? Because those numbers are getting bigger or smaller, it's making that repetition of that sine wave increase or decrease. Cool. So that hopefully is all making sense. It's kind of taking some of those things that we just worked in there, 3 lines of code. We've got a cool, you know, kind of pattern generator that we've made now, right? And so, yeah, that's looking great. This next section is going to talk a little bit about how we can fix some of these values, right? Because if we look and we go to we sort this by clicking the top, we can see, oh, the lowest one is getting to be negative. And that really doesn't make sense for a color, right? If we actually wanted to use this to color something in our renders or whatever, a negative value like that isn't going to work because it's going to cause all sorts of havoc in your render, right? So, okay, we need to just fix that. So let's, instead of having it go down to -1, let's add 1 to the whole thing, right? So we can take sine D and we can add 1 to it. And so now our lowest value is going to be, you know, 0.0002. So it's almost 0, but not quite. And that's because we've raised all the values by 1, right? Because we took our sine function and just added 1 to it. So it evaluates that sine function, then it adds 1. But this has caused the unwanted outcome of going up to 2, which again is way over white, isn't going to really work. And you can see these bands are super wide now because there's values that go all the way up to 2 in here, basically. And that doesn't make any sense. So, all right, let's take this whole thing. We'll make sure we kind of group these together using some brackets, and we'll do divided by 2. I'll just clean this up a little bit, maybe just compress that all together so we can see it. And now we should have our values good where we're staying within, you know, 0 on the low end and 1 on the high end. So that's all looking good. However, Matt brought up the point here that some people that work in programming and stuff frown on using divide, which is something I mean, so for me, I have learned in a rather small studio. So it was mostly me working in Houdini. And so there was nobody to frown upon me in my code. But it's interesting. I'd never actually heard that. So it'd be better to do something like multiplying it by a number in order to use a scale. I think the reason for that is that if you had something you're dividing by, you can get divide by 0 errors if you have a variable coming in that you're dividing by. Multiplying by 0 is fine, but dividing by 0 is like throws errors and is all sorts of crazy. So instead, we can just say here, we can say multiply by 0.5. That's the same difference. Nothing has changed. And there you go. Great. And then the next part here kind of talks a little bit about, well, yeah, we have 3 lines of code. Could you do it more compact? Is that better? Is that worse? And so let's look at this a little bit here. And what I'm going to do first of all is just, I'm going to pull over one more here just so we can kind of compare these two against each other. So I'm going to say 2A, or I'll say 2Alt. And we'll use this to kind of reformat this and compare them together. So I'm going to put a switch down again. And I'm just going to shift click on both of these and put them in there so we can just compare back and forth just to make sure that what we're seeing is the same, but that the code is written slightly different, because there's always more than one way to do pretty much everything with code and in Houdini, right? So, all right. So instead of doing it this way with these multiple lines, let's try it this way. So let's take this, we're on the Alt version here. So let's take this length at P, and instead let's take the scale here, and we'll just cut that out, and oops. We'll put a multiply in here, and I'll just paste that. And we don't actually need that line now. So now we have D equals length at P times CH scale. And so now D has got that scale built right into it. And the CD is being set just the same way it was before. So now we have 2 lines. And again, if we look here and switch back and forth, they should be identical. No difference. No values are changing here. No nothing. So all good. And if we wanted to go even another step forward with that, we could. So now let's take that and really really compress it into one line, right? So this next one is going to be even more compressed. So let's look at this. So here we're saying D, and D is actually this whole value up here, right? So what we can do is we can cut this out and replace it right here, right? And so now that is the same thing. If we get rid of this, bring this up, that is the same thing, right? However, if we, especially if we do this, I think this becomes way harder to read at a glance. And that, I think, is a great point that's made here in this kind of chapter, is that it's great to be able to write these nice little compact bits of code, right? Great. However, if it's hard to read at a glance for someone coming into it, that can be a big negative, right? So sometimes you have to find the right balance between how compact are you doing something and how easy is it to read, right? It's always something to keep in mind. So yeah, you can write it all as one line of code. Maybe that gets you some extra points somewhere in like some game or something. I don't know. But in the game of working in a studio, it might not get you extra points if you've got this insanely long piece of code in here that you're trying to follow all these different elements that are kind of coming together to write this attribute. Well, you want it to be clear. So, it's a personal preference thing. These are the same, right? We still are getting no difference between those two. But sometimes having it broken out into multiple lines like this can be a little bit better than just trying to pack it all into one. So, something to keep in mind. All right. Cool. Any questions about that? Hopefully that all makes sense. Kind of just talking some logistics there, but also a little bit of, best practices, maybe things like that. So, again, even if it's just you working on something, sometimes it's nice for your future self to be able to give yourself something you can go back and look at easily. So yeah, something to keep in mind. I've had many projects that I've opened up over the years that I worked on 1+ years in advance or after the fact, and just go, what in the world was I doing? Like, what was I thinking? This is insanity. I'm a lunatic. But you always kind of live and learn, kind of move on from those things, right? So anyways, any questions, or we can keep on trucking here, keep rolling through the old Vex world. Hopefully everybody's getting some stuff out of this, even if it's just little tiny tidbits like hotkeys and stuff like that. That was, for me, just going through a couple of these things was like, oh yeah, there's a couple hotkeys I never knew in there. That's great. Or little tidbits in there, it's good. So I think you always get something out of reading through someone else's like teaching of something. I think it's always something you can learn from. So I even if this is stuff I've experienced before and written, I think it can be good to learn these things from someone kind of new. So anyways, all right. Well, let's talk about the next function in this chapter, and that is distance. So we talked about length here, right? And length is saying what is the distance kind of or the length of this vector, right? From its root to its tip, how long is this vector? But in this case, we were talking about P, right? We're talking about position, and position is always going to be in reference to the origin. That's kind of by nature how P, the position of something works. You could maybe have offsets based on parents and things like that, but kind of at its root, at its core in Houdini, the P is always being measured from the origin, right? And so in this case, maybe we want to measure from a different like kind of origin point or from a different point in space. So in that case, something like distance is really great because it gives you the ability to set that second point. So let's talk about that and start kind of working through that. So I'm just going to clear this out because we're going to start a whole new thing. Goodbye. Cool. All right. So instead, let's work through this code here. So we're going to say float D again is equal to the distance. And we can see there's two different distances here. We're just going to use the regular distance. And you can see here it says returns the distance between 2 points. I'm going to say at P because that's going to get us the current point's position. And we're going to give it a vector in space. So we're going to use curly brackets this time because that's how you set a vector in Vex. So we're going to say 1, 0, 3, just like that. And then we're going to close our regular bracket for that function and do a semicolon because we're going to the next line. All right, so we're going to do the same thing. Actually, you know what? I'm just going to copy this in because that's the same code as before. I was being a dope. It's just the first one that's changing, so let's do that. All right, cool. So now in this case, we've changed that original function, right? The top function to distance. And this second point that we're evaluating it from is right here. So now all of our rings, these kind of concentric rings, are centered around 1, 0, 3. And so, 1 in the +1 in the x-axis and +3 in the z-axis, 0 in the y. Obviously, if we went up or down in the y, it would change, but it would kind of abstract a little bit away. So we're keeping it right on that kind of ground plane. So, okay, cool. That's great. But again, we're in that scenario where if we wanted to change this to something like 303, okay, now that's over here, but that maybe isn't exactly what we want. We want to be able to kind of adjust that and move that easily. Well, we're going to write another channel that will allow us to do that. So in this case, we're going to create a vector channel. And so here we'll say vector center equals, and we're going to say CHV center, just like that. And then what we do is, instead of leaving this vector here, we're just going to replace, we want this value here to be placed in here. So we're going to type center. So we're going to call that variable here. And now we have a way to more easily control our center point of this function that we're evaluating. So let's hit the little plus parameter button here. And now we have a center that we can tweak and work with. So now we can really quickly change where this is evaluating from. So again, this shows how the kind of quick iteration things that you can build into these wrangles. As you're doing more and more complex things, you'll be able to adjust them as you go along and have them evaluate kind of in real time as you update these different these different variables within there using these channels. So you're writing these channels right into a variable in Vex, which is super, super powerful when you get into obviously more complex things. So cool. So we've got the center there. And let's do another vector here that we can use to kind of play with the position as well. So instead of just doing, here we have the distance of P, let's add in another vector here. So we'll do multiply by, and here we do 0.5, comma 1, comma 1. And if this was a little bit more real-time feedback, I would say, what do you think this is going to do? But just kind of think about this as you're starting to see this. What is this going to do to our position, right? How is this going to affect it? If we're multiplying the position vector by another vector, what is this going to do? So what we're going to, let's just evaluate this and see what it does. Oh, okay. So it's now stretching that position vector by the secondary vector, and it's only stretching it now in the x-axis, because the rest of them are just by 1, so it's not scaling it at all. But now we're scaling the first component, the x component of position. So this position, the x component is being scaled by 0.5. So that is a really interesting way to be able to kind of adjust how this pattern is being scaled. Basically, you're able to kind of tweak it. Again, another thing that you can tweak on the fly. And so let's think about obviously how we would do that. And we would do that by making another parameter that we can evaluate using the channel function. So let's do this here. So this next section here is basically saying, okay, well, how do we go about doing that? All right, well, let's add another one in here. We'll call it vector position equals. And then what we can do is we can say here, let's just let's take this out of here, right? So we'll cut this out and we'll just bring this up here because we know we kind of want this. And let's take this position here. We'll copy that down into here. So now we're doing position and center. Those two are our 2 points that we're looking at. And instead of doing this crazy, just hard-coded vector, let's set this to be a channel, right? So we're going to say CHV. Sorry, let me just hit escape on that for a second because that's getting all crazy up there in the corner. CHV, and we're going to call this Matt called it fancy scale, and I like that. I like a fancy scale in there. So let's do that. We got some fancy scale that we're multiplying it by. So now we're back to this, and we're black. The whole thing is black again because we haven't said, hey, let's add that parameter in. So now we add that parameter in, and we probably want this to be 1, 1, 1, right? Because that'll set us right back to where we were. That's kind of the default that we want it to be. And as you can see here, we now have center, and we can change with our fancy scale these nice smushy rings and all. Well, now Y we can't change, but Z we can change too. So we can kind of move this all around and edit it as we see fit and scale it as well. So we can change how close they are to each other, you know, the different scales and stuff like that. So we can do all sorts of crazy stuff here. So I'll set this to 1 so it's back to where it was. But so adding in these different parameters and putting those into the Vex code in you know, intelligent places allows you to get these controls if pretty quickly and effectively. You know, this is just a pattern generator, you know, it's just doing just a radial ring pattern. It's nothing, you know, we're not reinventing anything here, but certainly it shows the power of these different parameters within Vex. So yeah, so there we go. Movable, squishable rings. All right. So the last thing that we are looking at here is this part I actually had a little bit of a hard time following along with, but what we can see right now is that scale is just a float, right? It's not a vector, right? So we're multiplying this right here is just a float. So if you wanted to change that to a vector here, if we wanted to say CHV, right, and we wanted to change this into a vector and hit plus, well, that's not actually going to do anything because it's already created. So what Matt was talking about here is that if you need to change one of these parameters, there's a couple different ways you can go about doing it. You can just go up here and say delete all spare parameters and then remake them. It's kind of the easiest way, right? It's kind of, he says it's the laziest way, but you know, whatever. It just kind of gets rid of it all and brings it right back. However, another way that you could do it is you could just take this scale and say more and delete just this spare parameter and then add it again, and it'll set, you know, your spare parameter here. And now you can, you know, change these values. Now in this case, you're not really going to see any difference. So I'm not 100% sure on that one there, but I might just be missing something on that. That totally is probably me that I'm missing it, because it's actually what it's saying here is that it's an implicit cast from vector to float, and we should cast it using the thing that we did before where we put float with the brackets. So yeah, anyways, basically the idea here is that if you're trying to change what type of parameter that you're creating, just hitting that button again isn't going to remake it because it's already made. It has to get removed in order to be made again. So just something to keep in mind. I'm going to change this back. I'm going to change this. Delete spare parameter. You can also click Don't Ask Me Again if you don't want to be bothered by that. But here we are again, back to having a float there for the scale. So yeah, okay. So that is the distance function. Any questions about that, about maybe why we did something a certain way or why we went about something? You know, drop it in the chat. See if anybody's got any questions or thoughts. Right. I'm going to say that probably we don't have anything too pressing. If you do, drop it in the chat. But I'm going to just kind of keep on rolling here a little bit. Why use length when distance is so much more flexible? Sure. Okay. It's a good question. So you could say that the distance is more flexible, But really what it does is it just gives you the option to have a secondary, point, right? It gives you that option to look between two specific points. It's really more about what are you doing with it, right? Because if you have like something like of velocity, right? And you want to know how fast it's going, you need to just know the length of that vector in place. Doesn't matter. You don't want to have to tell it each to evaluate, based on a certain position. You want to know based on that length of that vector, how fast it's going. Because if you take the length, if you do length of velocity, that gives you speed, right? The length of that vector is its speed. So that is a kind of a classic case of where you would use length. I use it all the time, to calculate speed. Now there's probably other ways to do. There's other nodes that do that as well. But if I'm writing functions in a wrangle and I need to get the speed, I'm just going to write length of v, and that's going to give me it's going to take that vector, turn it into a float that represents the speed of it. So that is where I would use that, because distance in that case, it's actually harder for me to calculate that because I have to make sure that I'm specifying where I want to calculate that from, right? Because if you're doing it from the origin or something, then it's giving you all these weird values and stuff like that. So that is why you would use it. Right. Yep. In this case, distance is your most flexible way. If you're doing something like this, like patterns or doing something based on, positions and things like that, using distance like this is going to be way more flexible. I'm sure there's other cases that might be similar to this that I'm just not thinking of, but there's always a million cases out there, right, for these things. But I think particularly if you're talking about position, using the distance function is going to be better. I think when you're talking about other vectors, depending on what they might be, a lot of times you just want to know, like forces and velocities and angular velocities and things like that. Sometimes you just want to know kind of the magnitude of that vector, how far it, how big it is, so how long it is. So that's kind of why you have length. And don't be confused too. There is also len, and that is a totally different function. So just keep that in mind too. You're wanting length when you're looking for the length of a vector. Len, which is a different kind of length, is a different function. But sometimes you might type len and be like, oh, there's a shorthand or something, but it's a different function. So just keep that in mind. Cool. All right. Well, let's talk a little bit about fit, because I think this is one of the most common, at least by me, I use this all the time, is the fit functions. And this is a way to kind of get past that add 1, divide by 2 step, right? Because really what you're doing there is you're trying to take values that are in one range and fit them into another. And doing that just purely with hard-coded math is kind of inflexible. And again, to get the most out of that, doing something like a fit function is really, I think, probably your best way of going about that, especially if you really easily can figure out what the value of your attribute is coming in and out of that function, right? So let's now talk about fit. So what fit does is you tell it the incoming minimum and maximum and the outgoing minimum and maximum. So it's kind of like this little transformation box that has two values coming in. It has a value coming in and parameters saying what those values should be. You should look at it between, and then you have parameters that set what's coming out of that box, right? So that function has an in and an out, two values on the in and the out that allow you to shape how those numbers are done. And so we'll see that here in a second. So let's look at this kind of this last section right here is what we're going to be really diving into here, because all the rest of it's fine, but we're going to talk about this fit. So let's take this and we're just going to actually get rid of this because we're going to rewrite this in a little bit of a better way. So let's do fit. And you can actually see that there's a couple other fit functions, and I would recommend taking a look at those if you don't know about those already in Vex and you're starting to do stuff, take a look at those other ones because those are really handy as well. But right now we're just going to look at fit. And we're going to say sine of d, just like we did before. right? So that's basically the same. But what we're going to do is we have four other arguments that we have to set basically of this function. And so those are values that we have to pass into this function for it to know what we want it to do. So the first one we're going to say is -1, then we're going to go 1, because those are what do we want to do with the incoming values. We want to look at the incoming values from -1 to 1. And now we want to set those to, we want to take those ranges and shift them to this other new range. And what we want to do there is say 0, 1, because we want to bring it into that color range, right? So there's the fit function. Let's put our semicolon at the end of it there. And really nothing has changed here, because now we have the exact same function, but we have something that is a lot more robust, right? Because now, even if we throw at it stuff outside of that -1 and 1, it'll still keep it kind of clamped to those values. Now there's ways to do other functions that are unclamped and all that kind of stuff, but this will make sure that your values are coming in and out and stay within those values. Now they could get clipped and they could all be 1, or they could be all 0 or whatever coming out of here, but that is the range of values that's coming out of here. They will not go above or below that. So that's just something to keep in mind. In fact, I feel like if we did, let me just see if we do this. I'm kind of going a little rogue here, but okay, sure. So now if we do this sine d plus 3, we've now pushed all those values out to the top of that range, right? And if we look here, all of our CD values are going to be all 1, right? Because they're all being clamped there. So this is kind of has a built-in clamp to it, which is really nice as well, because you don't have to worry about making sure that your values stay within that kind of, maybe in this case, legal range for the colors to be, right? So something to keep in mind there. But we can now taking that kind of concept in, we can then add something interesting like a built-in attribute, which one that you use a lot is time. And the key here is that time is capitalized. A lot, I think, I'm not sure if all of the not all the built-in attributes are capitalized, but some of the main ones like time and frame are capitalized. So in this case, we'll do d plus at time. And now we should see that this will change and evolve over time. And we don't have anything that we have to really write in there other than that one little line, that one little attribute that's built in. So that's super nice. And just to show you that there's other options, you could look at frame, but this is going to go quite a bit faster because frame obviously is changing you're changing an entire integer number every frame. So it's a little bit more like crazy looking. So time is usually is obviously the slower of the two, because it's saying what second, what float second are you at basically. So when you get to 24, you're at 1, so it takes 6 some seconds to get back to the original, right? So it's 6 and some change, I think, if I remember what Matt said earlier. But yeah, so that's I think a really cool way to be able to build these kind of time varying functions and effects without having to do a whole lot. You've got time built right into here, and it's going to evaluate without having to create any extra things from there. So something really nice to know. And I should say that if you ever forget what some of those built-in attributes are, if you drop down something like, let's see, like a point fop here, let's go inside of it here. These are the functions right here, right? Now, not all of these are come in by default, but like if you're trying to remember like, what's like these ones right here, like, is it PT num or is it num PT? And you can see right here down in at the bottom, it actually shows you which one it is. So if you ever want to kind of get a little cheat and try to remember some of those things, they're kind of listed here. Now, not all of these will come in by default. Like CD isn't just created by default, but these are kind of handy global values. And you can also see some of the things that are kind of off limits, right? Or are kind of special things like ID, like that's going to be an identifying thing. So anyways, this is maybe a little bit more, but just something to keep in mind that there are built-in things in Vex that you can kind of call up and use. So cool. All right. So that's fit, super helpful. And if you kind of think a little bit about what we've been talking about too, maybe you could start to see how using parameters and channels to call those different, to set these different arguments here within this function, how you could maybe create some really nice art directable things in there too as well. So so there's some different ways that you can go about maybe starting to see how these all start to play together and kind of build on each other as you go. So, just start to get the wheels turning a little bit here, right? So, okay. So more on code style is basically what we're talking about here is how Vex looks, right? So kind of what the style of it is. If you've ever worked in other languages, maybe Python, maybe, I don't know, even if you've done website stuff, whatever, all the different code types that are out there, JavaScript, I don't know, C#, C++, all these different things. So this is kind of something that's stylistically you're able to do in Vex. Now, if you're used to Python, you might be used to just saying just declaring a variable without having to say what type it is because it automatically gets set and some of those other things like that. So in this case, we're basically talking about how, math operations go. And I'm actually going to type this in because this really isn't going to, we can't really visualize this too closely, but we're going to just look at it here in this case. So, here you're saying here's a variable foo, and what if we wanted to multiply that by 5? Well, you could write it like this. That's totally legal. But like we said before, doing the times equal multiplier is the same and is much cleaner and much easier to see what's happening there, because once you see that times equal, okay, I'm taking that attribute and just multiplying it by 5, or that variable and multiplying it by 5. So there's also ones for adding, subtracting, and dividing, right? So you can see right here, plus equals, minus equals, and slash equals, divide equals. So so that's something to keep in mind. Hey, Bara, Happy New Year. Yeah, thanks for joining the stream, man. So, okay, so we have those concepts, right? And I think we talked about that a little bit, and hopefully that makes sense. We have that in our code already. So another thing you can do as well is do a bunch of operations in one line, right? So here we have foo. So foo times 3 plus 1 divided by cd.x plus n.y, right? And that's great. That'll evaluate and be fine. But sometimes breaking that up over multiple lines can actually be a lot easier to understand what's happening, right? So let's take this. I am going to just copy this in here so you can see kind of how this gets highlighted and stuff like this. And I think this is going to be angry. Yep, because we don't have foo. So what I'm going to just say is, I'm just going to say float foo equals 1. Sure. So now we just have a float attribute. So this allows it to do all the rest of these calculations. It doesn't really matter. We're not visualizing it, but I just wanted you to see kind of how this gets highlighted so you can see how the syntax kind of highlighting looks. So, okay, great. So we have this now. And now instead of doing this one line where it's kind of like, okay, it's multiplying by 3, then it's adding 1, then it's dividing by CD of the x component of CD, and then the y component is adding the y component of n. Instead, when you break it up into multiple lines here, you can see these different operators as you go through, and you can also make these really nice, comments for people that might be looking at it after the fact. So you're like, why did I multiply it by 3? Oh, that's to help set kind of the range of values we're working in. Oh, then we added 1 to make sure that it doesn't go into the negatives. Okay, cool, that works. And then we're dividing it by the x component of CD. That means we're reducing the range within the red value, and then adding the normal onto the y color, the y component onto it, right? So that is like a really kind of clean way to understand what's happening, why someone did something, right? Versus just seeing what the code is without anything, anything explaining it, right? But what Matt mentions here in the second thing is you could really easily trip yourself up if you miss one of these, right? Because this now has a totally different meaning, right, than what we had before, because we got rid of that little, if you miss that little operator before the equals. Now, and we do all this stuff, but then we're just setting foo to the y component of n. And that's it. So now it's just set equal to it. So all that top stuff is just kind of null and void at this point. Now it's just equal to n.y. So, and in this case, it would still be 1, n.y is 1 in this case. So it's something to keep in mind. And these are the little things that you have to kind of get used to seeing in your code and making sure of things. And if you did that and you're like, this result that I'm getting visually makes no sense, or the movement makes no sense, you can then go back and start to look at your code and say, what did I miss in here, and how can I go back in, try to kind of troubleshoot and go through it. It's a really important thing, I think, to kind of go through and understand. So cool. All right, I'm going to get rid of this stuff just so it's a little less cluttered. All right, great. So that's the end of section 2. And there's some exercises here. So some things to play with, try to kind of get in there and understand. So I would again suggest, if this is something that's new to you, go in here, try these exercises, try to, play with the speed of the waves, find out where that comes from in those functions. Like, what do you change, what do you multiply, what do you add to change the speed of them, make the waves different colors, things like that. So, and then I think where you start to get in the really fun stuff is saying, rather than affecting color, make them affect the Y position of the points. And then you can start to see how this becomes deformation, right? Because as that sine wave moves those points up and down, it's going to make these ripples, right? Again, it's not a particularly exciting example, right? It's something that's pretty straightforward, but you can see how a few simple lines of code with some nice functions, maybe instead of a fit and a sine, you do some sort of a noise function there, start to see how things start to kind of come together and make sense. So, so that is section 2 of the Joy of Vex. Does anyone have any thoughts, questions, comments about that? I'd love to help clarify anything if needed, and if not, then maybe we'll keep going. What time is it? It's like 9:45. You know what? I actually think that I'm going to stop here for this stream. I know we probably could get another one in, but I actually haven't really dove into the next one too deep. And I also would love to then hear anybody's feedback on this. Like, if I'm going too slow, going too fast, whatever, I'd love to hear people's feedback kind of on presentation and things like that, because this really is my first time, going through someone else's material and presenting it on our stream. So, any feedback would be super helpful in that case. So yeah, if you have any questions about what I've just did here, love to hear them. If there's anything I can clarify, before we're done today, that'll be great. What I'm planning on doing once I'm done with the stream is I'm going to go back in and make sure that it's annotated, or the chapters are kind of marked in it, so that you can kind of know the different sections and things like that. So if you need to go through it, you can kind of see. I'll probably do the kind of main sections of it, break it up by that, just so you can jump through a little bit easier, rather than it being just a, almost 2-hour block of video. So I think that's where we'll end it for the day. So, it feels nice to be back in the swing of things for 2023 here. We got 4 days under our belts for the year. So yeah, we're doing great. And so any questions, any thoughts, anything that you guys would like to add into the conversation before, we kind of sign off here for the day? Anything at all? I'd love to try to clarify or You're welcome, Matt. Thanks for doing all the hard work. I just get to sit here and just talk about it. So yes. Huge thanks to Matt. Thank you so much for, I just, I'm not going to say this over and over, but Matt's just a huge resource to the Houdini community. So huge thanks to him for just this existing period. So, I mean, this is awesome. Just this one little section. So if you ever have any questions about anything, Houdini, related, go to his wiki, because it is just, there's so many good little tidbits in there. It's awesome. And if you find yourself downloading his files and start looking at them and digging through them, right down here, click one of these buttons, because I was like, well, I have to at least buy the guy coffee for this or something, because it's ridiculous how many times I've been trying to figure something out over my years of doing this in production and go, oh, how do I do this one little thing with this point thing in Vellum, or how do I do this? And they're all here, and there's so many good little tidbits in here. So, yeah. So, Matt's been a great help, and hopefully I'll be able to maybe run into him, buy him coffee in real life someday. But, anyways, so that is the stream for this week. Next week, I'm going to try to shoot to do at least three of the chapters, so this doesn't take absolutely forever. And you know what, maybe if I'm feeling a little ambitious, I might try to do maybe more than one stream next week. We'll see how my weeks are kind of stacking up here as the year goes on. But this was super fun for me. Hopefully you guys got a lot out of it. Yeah, if you have any questions or are working through stuff through the wiki or in these exercises, post them in. You're certainly welcome to post them in my Discord server. If you have access to Matt's Discord server, post them in there as well, because obviously he knows a lot of these answers way better than I might. So so huge thanks to everybody for being here. I will definitely be posting out on the socials and things like that when the next one will be. But for now, we'll just say that for sure it'll be at the latest next Wednesday at the same time at 8 p.m. Eastern Standard Time. And we'll try to go through maybe three of these chapters next time and kind of maybe get a little more in. So guys, thank you so much for everything. I know this is the just beginning stuff, and it might be a little bit basic, but even as just a refresher, hopefully it'll be really good for all of you guys. So, thank you guys so much for joining me tonight. And, I'll be seeing you guys sometime soon. All right. See you guys next week. Bye.